Machine translation, which is a core application of natural language processing, has evolved significantly. While the concept of translating text between languages has existed for centuries, natural language processing techniques have enabled automatic translation with greater accuracy and fluency. Today, machine translation goes beyond simply text-to-text conversion. We can translate between spoken languages, generate signed language outputs, and even translate spoken or signed languages into written text. So if you look at the table of translation capabilities, we can go from text to text, text to speech, or text to sign. And the reverse is also true. And the same for speech and sign. So we've covered all of these different ways that we can translate with different inputs and outputs. Historically, approaches to translation have taken many forms, starting with rule-based methods, where we take a source text and process it through a series of steps guided by language and grammar rules. So the steps might include a morphological analyzer, a part of speech tagger, lexical selection, structural transfer, a morphological generator on the other end, and then some post-generation tasks, ultimately leading to a target text. We have also used statistical methods. For example, we might use a classification approach where we classify the source language using some classification technique, and then use a selector to choose words or phrases in the target language based on the classifications of the source language words and phrases. And then the outcome of this can be stored in a knowledge base, and a statistical translator can simply draw from that knowledge base to perform the translation each time. In deep learning, we use various models that are all based on the form of a neural network, and these are trained to perform translation between two languages. So you can have a neural network that takes as input text in one language and outputs text in another language, and we train different models to perform that translation between different pairs of languages. Neural networks have proven to be far more powerful than prior techniques to doing a lot of tasks, including language translation. So we can apply these specialized neural networks to our translation tasks and see quite a bit of benefit there. And finally, today we have the transformer model. And the image of the transformer model I have put here is from the paper. If we go to the link, I've linked to the Wikipedia page that gives you an overview of what Attention is All You Need is about. So this was a landmark research paper from 2017. It was authored by some scientists working at Google, and it really expanded on attention mechanisms, which was a proposal for deep learning architecture, and they created this deep learning architecture known as a transformer. And this is considered by some to be the founding document for modern AI, certainly for natural language processing. This creation of the transformer model became the main architecture of our large language models. And of course, our large language models are what we are using today and seeing in the news and such, ChatGPT, Google's Gemini, and so on. We see all of these models coming out, these large language models, and these were all driven by this seminal paper introducing the transformer model. So the name of the paper is Attention is All You Need, and you can link to the paper and read it here. So when we think about these large language models using the transformer model, so if we have large language models that are trained on vast amounts of text data. We can certainly use those to do translation, but you certainly need a lot of text. So training models for language translation requires a lot of text in both languages, and it requires text that has already been translated to use as training data to train these models. And since we don't all have access to that volume of text or the computing power even, to train such a large language model, there are existing pre-trained models that we can use that have been open sourced and made available to us. So Hugging Face is a great resource for natural language processing, where you can find a lot of models that are open source and available for use, and these models have been pre-trained with for different tasks. For example, some of the models might be multimodal, meaning that they're trained to do a lot of different modalities, a lot of different things. You'll have models that are specific to computer vision, and of course models that are made for natural language processing tasks. There's also audio tasks, which fall under the scope of language processing sometimes. And then other types of models as well, but we want to look at these natural language processing models. And if you see the tasks here, so text classification, token classification, question answering, we see translation. So translation is one of the fields for natural language processing where you can find pre-trained models. So we'll click on that. So here are models that are pre-trained to do translation, and these are open source and available to use. So you can search through these models. You can sort them. Right now it's sorted by trending. I can sort them by the most likes. I can see that the first model that's trending also has the most likes. It can sort by the most downloads, and so we see that again, this first model has been downloaded 4.87 million times, so obviously it's a very strong model. And so this is Google's T5 model, and T5 small, so small meaning that it's going to be a smaller model, easier to work with. You'll see down here there's a Google T5 large model, and so that's going to be a more concise model, but it's also going to be larger and take more computing bandwidth and resources. Let's look at the small model. So you can look at the different models, and each of the models is going to have a model card which describes the model, details of the model, its uses, and other details you might want to know about the model. And sometimes we'll have an inference API that you can directly test the model just using the web interface here. Of course, this isn't the way you want to do your research, but just seeing how the model's inputs and outputs look, this is very helpful. So here is an input text and then an output text, and so we see that this is translating English to German, and I can see that just by looking at the inputs and outputs. And then if you wanted to test something, you could say put your own input here. So we'll say training models is fun, and hit compute, and it's going to use this model to do the translation, and so that's the German translation. You'll see examples for different models. So here's a second example provided, and some of the models, you can do what I've just did here, test out the model. Or you can use these models in your own research flow. Hugging Face has very good documentation on how to use its models, so you can go through the transformers documentation and learn how to run inference using pipelines, which is one of the models, or one of the ways that's available to you to use their models. Another way is to fine-tune a model, so you can take a model that has already been pre-trained and use the baseline model as it is, or you can fine-tune the model if you have a specific task in mind and you have data available to you that you want to use to fine-tune the model to make it to improve the accuracy for your specific task. If we go back to our lecture notes, I have put a link here to the translation tutorial that's using Hugging Face transformers and fine-tuning a model. So this is a good tutorial to work through for language translation. There's a couple of videos in here, and it's a guide that shows you how to fine-tune a model to translate English to French. And you can follow along with this to start using the Hugging Face models for your own translation. And you'll see here there's an entire series for natural language processing, a series of guides that you can walk through. But I've linked to the translation one, as that's what we're doing here. And I recommend watching the videos. I think there's a couple small videos in here along with the code that you can use to translate, to fine-tune your own translation model. I guess there's just the one video up there at the top. And this gives you a choice of using PyTorch or TensorFlow. As I've stated in previous lectures, I think PyTorch is commonly used more for research, and TensorFlow is more commonly used in production. It's certainly good to come out of this class understanding one of those, but understanding both of them is something that I highly recommend. So, but you can choose as you go through these different guides, and especially going through this translation guide for fine-tuning and using a model. So in addition to showing you how to fine-tune, it's also showing you, as the side effect, it's showing you how to download data sets, so how to get Hugging Face data sets that are available to you, set them up for training, and then just do the training process. Now here's the second video here, so processing your data, preparing it for translation. And then how to use the some of the methods within the transformers space, and so that's going back to the transformers is the docs that I recommend going through as you're learning Hugging Face and how to use these models, working through these tutorials. So this will get you started on, in lieu of building your own transformer model, you can start using a pre-trained model in Hugging Face to actually conduct some natural language translation. Additionally, if you search the web, you will find models that are that others have created and made available and accessible online. So you'll find online models where you can directly translate tests. So you can use that for checking translations and seeing how good the quality of different translations are. And of course, quality is going to vary depending on the languages that you're translating between, in addition to the variance of the models themselves, the accuracy of the models. So doing language translation is a primary task in natural language processing, and the transformer model coming out is what really brought us to this place where we are today with our large language models that we're seeing all over the place. And speaking of, Gemini has given us a quote here, Gemini being a large language model from Google. And the quote from Gemini on natural language translation is, "Machine translation, a key subfield of NLP, tackles the challenge of automatically converting text from one language to another while preserving meaning and fluency." And that is the hard part of translation, right? Preserving the meaning and the fluency of the text. And the technology, of course, relies on complex algorithms trained on massive amounts of bilingual data. And machine translation has really revolutionized how we communicate, breaking down language barriers and fostering global information exchange. So translation is something, again, that's been going on for decades, generations, and now we're able to automate it so much faster and easier with our deep learning technologies and techniques.